we go. All right, so thanks everybody for joining us this morning. So we are looking at this set of notes. All right, and this top part looks pretty much the same as our first set of notes, except I've added one additional line about graphing to solve systems. All right, so on Monday we looked at how to check a solution, and now we're going to get into how to find a solution. Okay, so when we are looking at a system, so let's just go through our definition of what a system is again here. So we'll switch over to our, we'll do that real quick, switch over to our document camera. All right, so when we're talking about systems, all right, the system of equations are, again, two or more related equations that have the same input, usually x, and same output, usually y. A solution to a system of equations is where the ordered pairs x and y occur that make both equations true. All right, and that's what we practiced on Monday, was how to check to see if a solution that we get is actually the solution, actually works. Does it make them true? Okay, so what we're going to look at today and how and why this works is when we graph linear functions, we can tell the solution to a system by where both lines cross. Okay, the point at which both lines cross is going to be the solution to our system when graphing. All right, and why that is because a line, the line itself, represents every possible point that makes that equation true. So for example, the line that makes up y equals 2x minus 3, every point on that line that we would choose would make that equation true. All right, same thing for the y equals x minus 1. Whenever we graph that, every point on that line would make that equation true. Right, and so we need to be able to know how to graph, so we'll review how to do that real quick using, in particular, slope-intercept form. All right, we don't want to try and do this particular system of, or solving systems by graphing with using a standard form equation. So that's why we talked about in the last unit how to change a standard form into a slope-intercept, right? Because we will want to be able to do that because slope-intercept is a much more accurate, repeatable process for graphing a line than standard form is. Because standard form, we only get 2 points. With slope-intercept, we can get multiple, actually an infinite amount of points using slope. Okay, so let's talk about how to graph this one first. All right, and then we'll come back and graph this one and then see where they cross, because that's what we're going to be looking for our solution. Our solution will be that xy value where these two lines cross. Okay, so make sure to get that filled in on the blank because that's what we're looking for. All right, so in this, right, this is slope-intercept form, right? That's the y equals mx plus b format. And m, again, is our slope. Okay, and the b is our y-intercept. Okay, so we're always going to graph this second number first along our y-axis. Okay, even though it shows up in that order, we graph sort of in reverse. So we graph the y-intercept first and then use our slope to find other points. So our y-intercept for this particular equation is -3. So I'm going to come down here to -3 and put that on my y-axis, my y-intercept. Okay, now the slope is always a ratio. 1 second, let me just admit one more here. So the slope is always a ratio. So in this case, this slope is technically 2/1. If it's a whole number or integer, we always just put it over 1 so that we get the right up and over or rise over run format. Okay, so this is a +2 slope, +2/1. So that means that every time from this point, we're going to go up 2 over 1, okay? Now, when we were graphing these before, I said, well, we only need 2 points to make that line. Well, here's the thing. When we're looking for where this line crosses, where these two lines cross, we need to get as many points on this line as possible. So, and we want to be accurate about it. We don't just want to like, sketch it and graph it and hope that our line stays where it should. So we need to continue using slope to get every point that we can on this graph, okay? So I'm going to go up 2 over 1, up 2 over 1, continuously until I run out of space on the graph. And that's because I don't know where these lines will cross. It could be at any of these points, okay? Now that's fine for this positive side of the line. However, I need to continue having it go this way. Well, when I have a line that wants to go into the negative and it's a positively sloped line, the way to do that is to reverse both things that I've been doing. So instead of going up and right, I'm going to go down and left, all right? And if we look down 2, left 1 or back 1, right? Down 2 and back 1, that continues this line, okay? So we want to make sure that we get the line completely across this graph, not just 2 points. We want to get all the possible points here, okay? Now I'll go ahead and connect up these points on the graph as best as I can here. All right. So that's one of our lines. Does anybody have questions about how I got that line, how to use the slope intercept form, how we keep getting points, or anything along those lines? No pun intended on the lines there. No? All right. So looking at the next equation, all right, because we want to graph both, okay, not just one, we want to graph both lines to see where they cross. Okay, so on this line, I'm going to have a slope intercept form still. It's y equals slope intercept form. And this is going to be y equals x minus 1. In slope intercept form, I'm looking for the number in front of the x. Well, what is the number in front of the x here? Well, if there's no number shown there, that number is 1. Okay, technically, as slope being a ratio, it's 1 over 1, 1 to 1. Okay, now this minus 1 is my y-intercept. So I'm going to graph my y-intercept first. And that is a negative 1 y-intercept. Okay, the b is whatever's coming after that x. Okay, so that's my first point. Now I need to use my slope of 1 to 1 to get as many other points on this line as I can. Okay, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And honestly, I could keep going, but I'm going to stop there. And the reason I'm going to stop there is I just put another point on that line, right? I went up 1 over 1, up 1 over 1. That is going to be my point where they cross. So I can just go ahead and sketch this line a little. It doesn't have to go all the way across like the first one because I found where it crosses, okay? And where it crosses is that point right there, okay? So where it crosses is at 2 for x, 1 for y. So that's going to be my solution, 2, 1, okay? Now, if I want to use what we talked about on Friday and check this, okay, y equals 2x minus 3 was my first equation, and y equals x minus 1 is my other equation, okay? So if I want to check this, let me scoot this down so I get a little bit more space to show you. So checking this, I'm going to replace x with 2 and y with 1. And see if that's true. Okay, this is going to be 4 minus 3, which does equal 1. So that one's good. Okay, over here on this one, I'm going to do the same thing. Replace x with 2 and y with 1. see if that's true. 2 minus 1 is 1, so that one's good as well. Okay, do they actually have to both equal each other to be true? Yeah, for this to actually be the solution, if that's the correct solution, they both should check. So if for some reason, I will tell you today that you're not going to get any solutions that won't be integer values. Okay, so if you get lines, if you graph your line and you think, oh, it looks like it's crossing at 1/2, that's not going to happen on that worksheet. Okay, the solutions will all be integer values in some way. They might not both be positive like this, but they will both at least be whole number integer values. Okay, so that is how we graph to solve. Okay, any questions about that process at all? All right, goes back to knowing how to graph our slope-intercept form. So if we can do that properly twice, we should get to our solution fairly easily. All right, any questions at all on that example? All right, doesn't look like it. So what I would like for you to do is to, I'm going to give you a couple of minutes here to try this practice problem on your own. Okay, we'll go down here a little closer so you can see it a little better. So that is the practice problem that we'll try. Let me see if I can get that focus now. Focus. All right, so go ahead and try out that practice problem. So both of these have fractional slopes. Okay, so make sure that you're on this one, you're going to go up 1 over 2 every time. And on this one, you're going to go down 2, right 3 every time, right? So we'll assign that negative. And then when we want to go the opposite directions, we would go down 1, back 2, or up 2, down 3. So, or sorry, left 3. So however, whichever direction you need to graph, just reverse the directions on both if you need to go this way, right? Because if we do positive, positive, it's always going to go this direction, right? And this one's always going to go this direction. So make sure to just reverse so you can get to the left side of the graph there, okay? So I'll give you, let's see, it's 11:19 now. I'll give you, well, let's say 2 minutes. So we'll give you about 2 minutes. If you got any questions, let me know. You can send them through chat or raise your hand, and we'll try and get to those questions. All right, and there's not a place to put your solution, but if you want to put it off to the side, you can. Sorry, I forgot to put that. So your solution should be somewhere in XY value, somewhere over here, okay? All right, so let's see here. And again, if your line does, or lines don't cross at a place where you have 2 integer values for X and Y, all right, you'll want to reevaluate how you graphed. Did you graph your lines properly? And keep in mind that it's going to be a point, an X and a Y value, right? Someone just sent me a question and said, do they cross at -6? Well, is that -6 for X or -6 for Y? And what is the other value then? All right, so it's not just going to be a number, it's going to be 2 numbers, a X and Y value. All right, looks like Trevor's got his hand up. Let me go to him real quick. Trevor, what's up?
Yes, I'm confused about the whole thing.
So confused about graphing in general, or about how to find the solution after you've graphed?
Both.
All right, so what's confusing you about the graphing right now?
Just, I don't know, just how the fraction part, I'm still confused about. Like, how do I
Okay,
figure that out?
have you found your y-intercept?
Not yet.
Okay, so for that first problem, where would your y-intercept be? For this y equals 1/2 x plus 3, where is the y-intercept?
1/2.
So what format
I
are
mean,
we
not
looking?
1/2. Not
What's
1/2.
that?
3. It wouldn't be 1/2. It would be 3.
Okay, right, because it's slope intercept, right? So the second
Yeah.
number is our intercept, the first number is our slope.
Mm-hmm.
Um, we would have an intercept at 3, okay? So
Okay.
that point there. What is the slope telling us to do?
Go up 1, right 2.
Okay, so we can do that one time, but on this process, we don't need to, or we want to continue that each time.
Mm-hmm.
We go up 1 over 2, but we'll continue doing that until we get all of the points that we can fit on the graph. All right.
Okay.
We could actually probably get one more even over here. All right. But that's only filling in this part of the graph, this right side of the graph. How do I get it to go this direction?
Go down 1, go down 1, left 2.
Right. So we'll continue, just reverse everything we were doing.
Yeah.
So down 1, left 2, continually here. All right, so that would be our first line. All right, and we can just kind of sketch these together here.
Mm-hmm.
All right, so that's the first one.
Yep. I got it.
All right, so what about the second one?
Negative 2/3 x minus 4.
Yep. What's our point we're going to graph?
Negative 4.
Okay, so we'll go to -4 on our y-axis, right?
Yep.
Down here. And then if we have negative 2/3 as our slope.
You go down 2, right 3.
Okay, so down 2, right 3. All right, and if we keep doing that, down 2, right 3. Is that 3? Yeah. All right, so we've got, I think that's as well, we might get one more down here. So that's this side of the graph. What about going this way? Because it looks like if we only graph this direction, we're not going to see where they cross, right? Because they're going to cross over that way somewhere, right? So how do we get points going this direction on the graph then?
Go up 2, down, and left 3.
Okay, so that's up 2, left 3, up 2, left 3. And that looks like probably where they're going to cross, or should say probably that is where they're going to cross. That's the same point right there.
Mm-hmm.
So where these things cross is what we're looking for.
Right.
All right, so I won't continue sketching that out, but where they cross is right there. So what is that point?
Negative 6.
-6 what? What's our y value?
3.
Not 3. -6, what's our y value along here?
Oh, what do you mean?
So if I were to label this point, I wouldn't just say -6, right? I would say -6 for x, but what's my y value there?
Negative 6.
It's not -6 for y, is it?
No. Oh.
Like x is -6, but did I go up or down at all?
No.
So what's the y value there?
0.
0. So the solution to my system would be negative 6, 0.
Okay. All right, thank you. I got it
Yep.
now.
All right, let's see. It looks like we had another chat message come in with that. All right, so everybody, I know I did that with Trevor, but does everybody else follow along good with that explanation as we went through? So thank you, Trevor, for that question, and sort of allowed us to just segue straight into going over that. So that's good. All right, so if there are no questions on that, what I would like to do at this point is take a quick look at our assignment for today. So let me go show you your Eds B page real quick so that we can take a look at the assignment and where you will turn in the assignment by Friday. So here is your Eds B page. So you'll see today I added in this this assignment that will show up in the gradebook, solving systems by graphing worksheet. And if you scroll down on your Eds B page to Wednesday, it says this worksheet. So that hyperlink for the worksheet is where we're going. So we'll go ahead and open that up. And it will be this worksheet. There we go. So you'll see some slope-intercept equations, okay? You shouldn't have any situation where these lines won't cross, except number 5, okay? So number 5, we're going to skip for right now. So we're only doing 7 problems, so please make sure to skip number 5 here, okay? Everything else should have a point where those lines will cross, okay? And we'll talk on Wednesday of next week as to why number 5 would not give us a point where they cross on that. So let's see. Let me check on that, Miss Carrie. I'm not positive.
Okay.
I think maybe. If I send it to you directly, can you download it as a PDF then?
I have it. I just thought it would be helpful if I could annotate while I was in the breakout if I needed to, but that's okay. We'll figure it out.
Okay. All right. So we'll go ahead and split into groups here. If you don't finish this up in class, keep in mind office hours, both today and tomorrow, and then actually Friday morning as well. So today and tomorrow are 2 to 3, and Friday morning for me, 9 to 11. All of your assignments for me are due by 11 on Friday morning, okay? So make sure to get both this and the IXL done. We'll go ahead and stop the share so we can get into our breakout rooms here. Let's see, 2 breakout rooms. So let me carry. Let's see, we got 1, 2, 3, 4. Let's see, 5, 6. Looks like 6 students in with you, Miss Carrie, today.
Okay.
And the rest will come with me. All right, so guys, let's use this time to ask good questions. And we'll see you in the rooms. All right. All right, guys, we're all in, I think. So if you got any questions at any point,
Out of way to
other-
chat.
what's that? Is that Toby?
Sorry, I was just singing.
Oh, okay. So the only other problem I don't know about Warren, but want you to make sure you pay attention to is number 3, because it's got that y equals 4 equation. Can anybody tell me what type of line y equals 4 will be? I heard somebody say it. Who was that?
Nate,
Nate? Okay, and what did you say?
horizontal line.
Right, it's a horizontal line at y equals 4. So we would have just a horizontal line going across 4. So somewhere along there is where that intersection will be, all right? So just careful with that one. Make sure that you're graphing that as a horizontal, not just a point, okay?
What about for number 1? Because it's like you go down 7 and then right 3.
Mm-hmm.
So I'm trying that, but they never, I guess, collide, or like there's no intercept.
So if you go down, where is your intercept for that one that has the negative 7/3 slope?
It starts at +4.
Okay, and it goes down 7, so in over 3, right?
Yeah.
Okay, and what about,
Oh, okay.
and then the other one has a -4 intercept and goes up 1 over 3.
Okay, thank you.
Yep. And guys, don't forget to list, there's no place on this. Don't forget to write what your actual point is. So, for example, on that one, wherever those things cross, make sure to list your X, Y value. You can just write it down below the graph if you want. But make sure to list your point somewhere on your work.
For number 2, for the second one, would we make it 2 over 1? Mr. Peters?
Yes.
For number 2, would we, for the like y equals 2x minus 2, would we make 2x 2 over 1?
Yeah, always turn any integer value for slope into a ratio. So yeah, put it over 1. While I'm thinking about it, let me put your dojo points in for showing up today.
And where's Joshua Teo?
What's that?
Who's Joshua Teo or Cheo?
Joshua Chow. He is a a student who was just observing, a student from a different grade.
Oh.
Can you help me with number 3?
Yeah, is that the one with the horizontal line?
Yeah.
Okay. So what's your question?
So I went. So it goes -7 over 1. So you can't go down -7, but then you go up -7 and over 1. So
Mm,
then
which direction over did you go though? Did you
right.
left or right?
I
So
went right.
if it's a -7, remember one of your directions has to be a negative direction. So if you're going up, that's a positive direction, which means you need to go left to make it negative.
Okay. So then y equals 4. We just put it on 4.
Yeah, but remember, it's a horizontal line all the way across.
Yeah. Okay, thank you.
Yep. So how many of you have an iPhone?
Me.
I do.
Okay.
I do.
I know, because I know like some of you are taking pictures of your work like this, and that is okay. But did you know that your iPhone actually has, I believe it's if you go to notes, just double check.
Telling us how to cheat, so now we can't take pictures on our phones anymore.
No, you can take a picture. I'm just saying that I believe if you go to, I think it's notes. Yeah. If you go to notes on there and then start a new note, when it brings up the keyboard where there's a little picture of the camera, right click on the camera and it says scan documents. So that'll actually allow you to have a scanner so that it turns it into a PDF for me so I can open it in a more reasonable fashion, I guess. Then sometimes just a picture will do. All right. So if you've got that, that would be great if you could use that feature for me. It's just easier for me to see your work in a scanned versus just photo. Okay. So
Oh, that is cool.
and if you don't have an iPhone, I have no idea how to create a PDF on an Android, but I'm sure there is a way.
So for number 6, there's y equals -x. So since x and y always equal 1, would it just be -1?
You mean the slope for the y equals -x plus 2?
Yeah.
Yeah, it would be -1/1 technically.
Okay. Thank you.
Yep. So Julian, what is your picture of there? Just a random beach or? Can't tell. Can anybody tell? Oh, dogs are snoring in the background there.
Are your dogs happy that you're home?
Yes. So 2 of our foster dogs have meet and greets this week, so I might be back down to 3 by the end of the week, so that would be good. One on Thursday afternoon and one Saturday afternoon. So. All right. Also, before, no, we're not quite done here, but before we go, please make sure to go do your attendance for your homerooms if you haven't. We're having people miss classes or miss attendance that we know are coming to class. So please don't forget to do that each day. Set yourself a reminder or something in the morning at 9 or whenever you're getting up. That should be maybe the first thing you do. All right.
I'm done, so have a good day.
Thanks, Cassidy. You too.
Hey, Mr. Peters.
Yeah.
I'm kind of confused on the solution part, like how to find the solution.
How to find it? It's where the lines cross. So if you're not getting a clear point where they cross, you may need to just double check your graphing, right? Like if you can't say, all right, that's definitely at 2, 3 or -5, 7, whatever the point is where they cross. If you can't tell, then you
Okay.
may want to go back and double check your graph or graphs, depending. Like sometimes you may have graphed one of them wrong and it's going to throw the whole thing off. So
Yeah. Okay.
it should be an integer value point somewhere.
Okay.
All right, I'm gonna go ahead and stop our recording here. So we won't close out class yet, so we got another 10 minutes or so if you guys want to keep working in group here. I'm just gonna go ahead and stop the recording since I think we've gotten most of our questions out of the way.